So actually, before I give you guys the convention for what domain we restrict sign to, I'm going to go over one more thing, and that is our notation. That way we know how to write it down. So when we're talking about inverse functions, you already know that the inverse function notation is at -1. So here's some notation. If we have a function f, our inverse function will be written as f of f to the -1 of x. So this is our inverse function notation of f. So f of x and f inverse of x is written like this. So these are inverses. In much the same way, when we have sine of x, our inverse function notation is written as sine -1 of x. Okay, so that is our inverse function notation, but I want you to be super careful here because remember, to find the inverse function, we're switching to x and y. So right now, when we have our y is equal to sine of x, what is the input to our x there? We know that that x is represented by our angle of rotation, so it is an angle, either in degrees or radians, whereas y is the height. And since we're switching our x and y's, when we come to our inverse function, so y is equal to inverse of sine, now this x is no longer the angle, but what we're plugging into here is our height, and what we get back out is the angle. So essentially it's a way of solving for the angle, and that angle would be the inverse sine, so sine -1. Okay, so let me go over this notation just a little bit more. So above you see a couple of my points. Let me zoom out a little bit. So on top you already see a chart with all of my points for the sine function. So if I were to make a chart for the inverse sine function, instead of plugging in the angles as I did here, what I plug into my inverse sine is I'm going to plug in my height. So for example, if I have a height 1/2, then I want to find the inverse function of 1/2, inverse sine of 1/2, and I should get an angle back out. So basically what I'm saying is when you see the inverse sine notation, the question you're asking yourself is no longer what is the height at this angle, but what is the angle that I need to rotate to get to that height. And that height right now is 1/2. So what do I need to rotate to get to that height of 1/2? And looking at the chart above, I know that it's either 30 degrees or it's 150 degrees. And knowing your coterminal angles, you know that there are an infinite number of degrees that I can put here. I can put 30 plus 360, 30 minus 360, 150 plus 360, 150 minus 360. All of those are all angles that give me a height of 1/2. Then that becomes a problem. Because remember, functions, I take in one input, I need to only have one output here, but here I can actually have infinite number of outputs. And that is the reason why we need to restrict the domain. So now I can finally come back to our idea of restricting the domain. So let me come back to that idea. So to restrict the domain, restricting the domain helps me be able to choose one of these values. Do I choose 30? Do I choose 150? Do I choose 30 plus 360? And coming over to my graph here, if I have the height of 1/2, do I choose this point here, this point here, this point here, or this point here? Now if we restrict the domain, say for example, we say we only want the inverse sine values where our domain is just from, or our range, sorry. Yeah, where our sine value, we just want our sine function to have a domain from -pi/2 to pi/2. That means we're going to restrict part of our graph. So let me extend my graph of sine here. So this is actually a convention, because if you go ahead and take a look at the sine graph, what parts of the graph can I choose such that the height will no longer there will not be multiple heights? I can choose this piece right here, from the maximum point to the minimum point. So from, this is pi over 2, I believe, and this is 3 pi over 2. If I just choose this section of the graph, then when I do the horizontal line test, you'll notice that it doesn't repeat the height anymore. But I don't have to choose that piece of the graph. I can also restrict my graph to the next part of the graph, from here to here. And you notice that from here to here, the height never repeats. So there's actually many different places you can restrict your domain, just as with parabolas. But in this case, by convention, most mathematicians or most math textbooks will have you restrict the graph from here to here, and that would be negative pi over 2 to pi over 2. And that's just because the numbers are close to 0, so it's easier to work with. But usually your problems will specify that. So I'm going to come down here, and I'm going to say, for the sine graph, I just want my domain from negative pi over 2 to pi over 2. And if you take a look, pi over 2 here is our minimum point, which is negative 1. Pi over 2 here is at our maximum point, which is at the value 1. So that means my range goes from negative 1 to 1, which covers all of my heights, which is great. So that's what I wanted. So now, if my domain and range is specified as such for my sine graph, then when I come to my inverse sine function, my domain and range for my original function is switched, just like our x and y values are switched. So now my domain here is negative 1 to 1, and my range here is from negative pi over 2 to pi over 2. Or, if you want to represent it in terms of degrees, negative pi over 2 is just negative 90 degrees, and pi over 2 is just 90 degrees. And that way, when I come over to my table here, originally I was looking for inverse sine of 1/2. And did I want to choose 30 degrees? Did I want to choose 150? Well, looking at my range here, I can only have the values between negative 90 to 90 degrees, because that's a part of the graph that I chose. Therefore, I don't want that 150. I want that 30 degrees. And you notice that there's only one height such that it is 1/2. There's only 1 degree such that you get the height 1/2 within this range here. So now I've restricted my domain to a place where my inverse is a function. There's only one value that fits. So I do want to give you another example. So let me go back to my table up here. So my table up here, I also had the height root 3 over 2. And root 3 over 2 matched up with 60 degrees and 120 degrees. It matched up with pi over 3 and 2 pi over 3. So let me write that example here. So if I wanted to find the inverse value of root 3 over 2, so sine inverse of root 3 over 2, I have the problem of choosing between 60 degrees and 120 degrees. Which one do I want to choose? Well, taking a look at my domain and range, my domain is negative 1 to 1, and that's okay, because root 3 over 2 is between negative 1 and 1. But my range here can only be from negative 90 degrees to 90 degrees. So which one fits in that interval? Well, 120 is too big. It's past 90 degrees, so I don't want that 120. Do I want that 60 degrees? Well, 60 degrees fits inside, is greater than negative 90 degrees, and it's less than 90 degrees. So 60 degrees is great, and that is going to be my inverse value of root 3 over 2. So that is all I wanted to say about sine. In the next video, I'm going to just quickly go over a few examples on cosine and also give you the convention for what we restrict the domain of cosine and tangent. So for sine, you'll want to remember that we restrict the domain to negative pi over 2 to pi over 2. And that's how you determine which value you want.